chlorophyll. This gives you a conclusion of what is going to happen. Okay, for strong acid, magnesium, so it becomes completely fine with the alkaline. Okay. Phospholipid. This structure is exactly the same as chlorophyll. The only difference is there's no magnesium in the center. So we also call it D-magnesium chlorophyll. They have a nickname called D-magnesium chlorophyll, if you want to understand that terminology. Okay, carotenoids. What is carotenoids? That one we want to mention. Because beta-carotenoids, you know that. Do you like carrots? If you like carrots, you see that orange color, that is beta-carotenoids. What is beta-carotenoids looks like? Very large. One goes here, they go this way, they go here. This is about 20 conjugated long chain of double bonds of the carbon. They also have cis and trans configuration, same as you fatty acids. Trans configuration usually deep color, cis light color. Okay? Now, for a yellow color, this carbon must more than 7, indicates a yellow color. The trans configuration could be easily become a cis configuration if exposed to light, heat, and acid. Therefore, the color will from dark to light. Did you ever notice if you have a carrot, if it's raw, it's very orange. When you cook it, the orange will a little bit light. Okay, so just let you know, because the transfiguration becomes cis. Now, we have a so-called prefix to explain the carotenoids. If you see NEO, at least one cis double bond. If you see PRO, which is polycis carotenoids. Now, to evaluate carotenoids, there is a two system, which is called carotenes. This basically is a hydrocarbon. The second one is called saxophiles. Saxophiles, this will be a combination of ketones, mesosaxones, hydroxyl, etc. A lot. It's going to be a good combination. Okay? And another system to evaluate you based on the cyclic. We call it acyclic, monocyclic, and bicyclic. So just some of the characteristics right here. You can all read these. It's yellow to red, orange, water insoluble, only soluble with like alcohol, those products, formulated with stabilizer as ingredients. Produced from chemical synthesis. It's a very good antioxidant, has a pro-vitamin A activity. Therefore, lots of the products, we want to see the vitamin A, because vitamin A is a fatty acid. Is a fat soluble, it's not water soluble. It is difficult to determine. So we measure pro-vitamin A activity. We measure the amount of carotenoids. Very good, stable with a wide range of the pH. When the band is put in the refrigerator, we call the band ages, they may refuse a ring, okay, which means they may lose the color. They must be well preserved and hydrated to prevent stability issues. Why? This is the reason. 40 carbon carotenoid in any of the condition could be go down. Any way you like becomes these small carbon byproducts. Therefore, has to be stable very well. Now we're not going to go over all these. A good example, a good example. Beta carotenoids going through oxidation become retinol, and retinol reduced to become retinol A, vitamin A. That's a premature precursor products of vitamin A. So where the vitamin A comes from? Comes from beta carotenoids. Okay. This is in our textbook, which is tells you. Instead of we are measuring vitamin A for all these produced in the vegetables and even orange juice, we are measuring provitamin A for these. Because these will be indicated how much vitamin A in their final products. And here we use IU. What is IU? You know that in your nutrition class all the time. I wrote here, instead of some people never know it, it's called International Unit to measure the fat-soluble vitamins, including vitamin A, D, E, and the conversion them to milligram depending on the nutrient. So for the vitamin A, 1 milligram of beta-carotenoid equals 1,667 IU of vitamin A. So this tells you we do not really measure vitamin A in those fresh produce or vegetables. We are measuring provitamin A, actually coming from the beta-carotenoids using chromatographer methods. This is the example tells you, if a tomato, if a good tomato, a red tomato, during the refining process, the lycopene will be significantly increased. And you see it almost like 700 increased, from 0.11 to 7.85. Carotenoid is slightly increased. The others no big difference. Now lycopene, by the way, is a very good antioxidant in a tomato. It's said it has a very good anti-aging and